Another thing that I learned is in manufacturing, design engineers and nurses. So here's the correlation between them two. A design engineer, his whole DNA is to make something non-standard, special, custom type thing and have an urgent, and their drive and urgency is one thing. Nurses, they don't have the time. Six Sigma, to get to the root of a problem, takes time, and they don't want to hear that you have to go test something or do something. And so they're more reactive. They remind me so much of a design engineer. They come up with a thing they think is going to solve the problem on the fly by that part of their brain, and then just go do it. And what happens is, if you don't take the slow approach and only change one thing at a time, you just keep running around trying to find the problem.
Welcome to Why They Fail, the podcast that pulls back the curtain on why continuous improvement efforts fail. Buckle up, because we're not here for motivational fluff. We're dissecting the short-sighted decisions and leadership agendas that sabotage CI success. But don't worry, we'll clue you in to the few simple keys to success to avoid these pitfalls. If you're ready for the truth, let's do this.
Welcome to episode number 11 of the WTF podcast. Titled From Factory Floor to Operating Room, we will explore how the business principles of manufacturing are revolutionizing the healthcare industry. I'm your host, Kevin Clay, and today we have a fantastic guest who embodies this very concept. With over 40 years of experience, our guest is a Lean Six Sigma Black Belt who has applied his expertise to everything from tube mills and machine shops to hospital operating rooms. He has an impressive list of achievements, including reducing cycle times from 72 hours to 12 hours and cutting missing instruments in surgical sets by 70%. Please give a warm welcome to Eddie Conklin.
Eddie, what was your catalyst? What got you into continuous improvement, and how it's led you to where you are now?
I'm 68 years old, so I'm going back decades. When I was 16 years old, I started out. My dad, and throughout these podcasts, I'm going to call things my father's factory. And the reason I do that is I worked with him in a couple different locations, but he was always either the senior leader or vice president of manufacturing. So at 16 years old, I worked for my dad. He had a factory down in Ward Leonard Electric Company down in Mount Vernon, New York. And he stuck me into the tool room. And I was a tool room helper, basically starting from scratch, with, believe it or not, German tool makers, the whole story. But what was interesting about my time there, and I worked there a couple summers, was I worked directly with industrial engineers. And what's threaded throughout everything that I talk about was that time I spent with these industrial engineers, because they were responsible for process improvement. And back in the day, process improvement was important because back then they had time studies. So what they would pay people on piecework. So the industrial engineers were just solely responsible for improvements in the workplace, not only speed and efficiency, but also for safety. They were the ones. So I worked with them directly at Ward Leonard Electric Company in Mount Vernon, New York. My first big project working in the tool room was I had to take and machine down these pieces of metal that all to one size, because they were trying to send it through a conveyor oven, and it was all different sizes, and the belt kept ripping. So when the belt ripped, they'd also asked me to change the belts. Finally, this industrial engineer, we walked upstream to say, well, why are we getting all this thickness of metal? And what it was the guy was brazing on these plates together. He didn't have a jig or a fixture. So I saw, once he made that jig and fixture, it literally eliminated the milling operation, and they could go right through the belt, the belt conveyor belt, and not have to change the belt. So that was like my first project that kind of embedded into my life. I got to see things differently. After I left, I was working for them. And then I went, after high school, taking metal shop in high school, of course, I went to a company called V&O Press. My dad left Ward Leonard and went down to New Jersey for a company called Heinemann Electric Company. At V&O Press, I was an apprentice, more than apprentice toolmaker. I was on evenings. I was a machinist type position. What's interesting these days is they talk about something called SMED, and SMED is single minute exchange die. And basically what it is changing tooling efficiently so the machine is to minimize the amount of time the machine is not running. And so back then, and I'm talking in the 70s, we were doing some elements of SMED by putting special pins and bolster plates for quick changeover of these dies. And the two companies I remember were Whirlpool, a wash machine company, where they were punching the holes in the barrels of the wash machine, and they wanted to do it from the inside out because the old process, they had to grind the burr out of the inside of the wash machine. And the front wheel vehicles were very popular back then, and that was the bearing on the drive. And again, they wanted to punch it instead of machining out all those type things. So what's significant about that is, I'm embedded with all these different things. And then years later, and this was probably, I don't know, maybe 8 years ago, we were doing a similar OR renovation at a hospital. And one of their big things were they wanted to have room changeover. And so, of course, I went in there and I said, hey, how come we're not doing any kind of SMED? And of course, nobody knew what I was talking about. So, but what it is to change the room over because they wanted to get more OR cases during the day. And the driving force behind single minute exchange time is to distinguish between the internal thing you can do and the external, where you have everything ready and you don't have to wait for things. So you can change it around. In the ORs, they have these instrument sets. Each surgeon has their preference cards of what instruments they would like, and they put it in a container that gets sterilized. One of the things we saw right away were some of the sets weren't available, or they had to go get a set, or it was sitting somewhere else. So when we worked on room turnover, we made sure everything was available that could be there. And, you just go right down the list. You measure the time. We used to measure wheels in to wheels out. And so from the time a patient comes in to the time they go out, that was the part we worked on. Well, before the wheels came in, there were some things that you could do to make the time in the room where the patient, you didn't have to wait for the patients. That's how SMED was used in the ORs.
That's amazing that how you can correlate from manufacturing to to healthcare, because all you're doing is you're processing something. You're processing either a part, a transaction, a service, or a person.
Well, a down and dirty one too was, they have to terminally clean the room between each case. And so we improved like the EVS, which is the people that actually clean the room between the rooms. We made sure they had everything they needed. So as soon as that room, you'll hear over the loudspeaker, which is an andon, by the way, hey, room 5 ready for turnover. So those people would know that get everything you need because I want to turn the room over faster. So each person has their own element to knock out to reduce it.
And the term andon, it's a visual signal or
Yeah.
auditory signal.
Light could be a sound, could be whatever. Could be like if you pre-text the anesthesiologist that, hey, we're just about winding down on this room, give them a heads up, things along
Wow.
that line. Especially these days,
Okay,
believe it or not, some surgeons are doing double rooms. So that means he's doing a knee in one room and they're setting up the next room. So so he goes right from the one room, he hands it over and he jumps into the next room. And, so if you did your value stream mapping, you would see the patient is the number one value and the second one is the surgeon. So if you did a value stream map, you would see he has got all value. He's going right from one room right to the next.
so he would be almost considered the constraint. The less time that he sits waiting to do something else, and the more time he's adding value, then that becomes the value in the process. That's awesome. I didn't think of it that way. You were talking about sets, and I think you said that sets were inventoried that was at another location,
Yeah,
and they
so
had to go get those sets.
Yeah, so traditionally, if you go to most ORs, the smaller ones like surgery centers, they're probably pretty efficient. But in most operating rooms, I think we have 20 operating rooms. Traditionally, all the sets used to be down in a different location, in like central processing where they did the sterilization, or a sterile storage room. And traditionally, everything was stored there, and then they would do a kit list, take the sets that they needed for that case and bring them up to the OR. Now that's fine until all of a sudden the doctor or something needs an additional instrument set or an instrument. That would require the OR to call downstairs. The person downstairs would have to stop, look up and find that set and bring it up to that surgeon. When I started working with Title Health, I was lucky enough to be on a team where they were doing our renovations, and we put all the instruments and materials up in the sterile core. The sterile core is where everything is that they need to operate the operating rooms. And that was against the normal trend of tradition. And basically, so everything is
I
up
bet
there.
that
So
was hard for them to adapt that change because it wasn't what we did normally.
and it wasn't so much the instrument sets as the material. They said there's no way all this material is going to fit up here. And so my partner, her name is Laura, came from Cardinal Health for 30 years. She was able to reduce what was in that core down by 40%. We tried different methods. We tried Kanban cards. We tried all different things, but we ended up using something we called right sizing. So what she did is she figured out her par levels, so what she was going to use for I think the week and the day, and she literally set the shelving up to the minimum par level. And what that did was dramatically reduce the amount of material, but also from taking the inventory each day, you just do it at a glance. You walk up and down, and they still do it to this day. They walk up and down the aisle, and they can literally see what to order. So if they get a surge of a couple days of one product, you would just look in the bin and see that it needs to be filled. So she did an awesome job doing that. Otherwise, they wouldn't have allocated the space for us.
This sounds like 5S to get rid of
Yeah. Oh,
what
yeah.
doesn't belong, like the space,
Yep.
and
Yep. Yeah,
you probably
exactly.
have visual signals or colors that help you understand what you're missing or min maxes. So you've got all
Yeah.
these
Yeah.
visual
That's
signals
correct.
that are in the operating room.
Well, and the other thing is once they gained confidence when Laura did this, because we had a lot of hoarders. So what happens is when you run out of something in a hospital, you never want to run out of it again. So you overorder, you hide. And then the other thing that's totally different in healthcare is expiration dates. So you have to stay on top of all that. So your rotation of your stock, you have to stay on too, the amount of turns. But I know they're moving to automate it. Laura was not a big computer person. She says we can never run out of anything in this OR. She had somebody touch it every day. Every day they physically go up there and touch it. And believe it or not, it was less than walking around with a spreadsheet or whatever when you set it up in a visual
Wow, wow.
um,
So it's
right
almost
size.
like
Yep,
cycle counting. Cycle counting and Kanban and min maxes, and all of a sudden you're managing your inventory through data rather than, oh no, we need something. And then we order 4 times that amount. And then we end up with half of it going bad because it expires.
that's correct. And we tried their traditional Kanbans. The cards were missing. When you're in healthcare, you can't have an excuse. You got to always have something. And she kept it for years and years. She retired 2 years ago, and I think she went several years without a stock out. She was
Wow.
able to,
That's amazing.
she had a change. Don't get me wrong. They had other things, subs, and she had local hospitals around the area that she would have to scramble once in a while, but nothing that affected the ORs.
Let me ask you this. A lot of people say, this is more lean than it is Six Sigma. What you did there with the OR? How did Six Sigma data analysis take part?
Well, I can give you an example downstairs in central processing, and I'm sure Laura can tell you several stories upstairs. The ORs usually operate with something called block scheduler. I don't know if you heard this
Okay.
or not. It's not like
Yes.
it's not in manufacturing. They have block plans. And so what happens is they allocate blocks to different surgeons. But the result of that is the OR demand that's coming downstairs to the central processing is off the map. You could see that we're going to have 20 cases today and then 30 cases tomorrow and all different mix from ortho to heart and all those type of things. So what I did is I had to come up with a way to staff to cover all the variation. And so what we did is we measured it for a half a year, figured out what they said we were going to need, how many case carts. I broke it down to case carts coming down to decontam of all the mixes. I couldn't go by the OR schedule. I went by case carts. So what I did is I measured that, and I had a year of what they said was going to come down and what actually came down. And we kind of
Right.
figured
Right.
out what the safety factor is. And we came up with like a scatter diagram. We said, okay, what is it that we have to fix? We have the anomalies that we have to adjust to, but what is like the amount of people we should staff to cover it. When you go to ask for FTEs in healthcare, you have to have an act of Congress to get somebody. So, and you don't want people standing around. So you really have to be flexible enough to adjust it. So through measuring that, we were able to come up with a staffing plan. And then, and what we did is we also asked for some standby employees. But in the morning, part of that is the morning we look at what cases are today. They give us the final schedule in the morning, and we're able to predict how many people we're going to need for the day.
Let me kind of speak back to that. So you put some lean things in place to kind of shorten the changeover. You put some
Yeah.
best things in place
Yeah,
to make sure
and where
that
this and how this all came about was we had a breakthrough. So when I was in this meeting with all these OR managers, I said, if I could do one thing, what would it be that would make a major improvement? And they said, even if you think it's going to be impossible to do, and they said, if you can have everything done by 7 o'clock in the morning, so we don't have to call down to central processing every day. So that was the driving point behind my plan with Lean and Six Sigma, because now I had a date. 7 a.m. they wanted everything. So I worked backwards. I took that number, the available time, the available resources.
our listeners understand that you use some lean concepts, but you also use some data analysis. You probably found there were some key inputs that were causing some of those outliers, right? And I think you
Yes.
identified that with the having things done in the morning, making sure those things are staged. And these two different concepts melded together to improve a process, a healthcare process. So that's awesome.
Yeah, the other part is I talked to you earlier through LinkedIn and stuff about myth busting. One thing that data does for you, so many times you go into a meeting and they refer to a study or they tell you about different things. And when you do your experiment, that gets me back not only to healthcare, but something, projects I did at Plymouth Tube, that when you do a design of experiments, you're surprised on what actually causes the relationship between factors. So I always am. Even if you're an expert and you think you know exactly what's going on, you get stunned. And that was the biggest thing through my Six Sigma with Sam and everything. When I was working with him over the Plymouth Tube, I was just totally amazed. I was not a Six Sigma guy. I was a lean guy. And then when we had a project over at the steel or the tube mill, and I did my project that I got my black belt on, my boss literally stopped me halfway through the project. So my project was to eliminate a knuckle on extruded stainless steel. And so what we were doing is we found the 4 factors when we extruded them, we thought caused the knuckle. One was specialized tooling versus regular tooling, lube, the mano reduction, and the speed of the draw. Well, the one that we couldn't believe was they said the special tooling had no effect on the knuckle. And we were spending $250,000 a year on special tooling to prevent knuckles. And when we ran our testing, of course, the GM made me run it several times because he couldn't believe it. We found it had no effect. The other factors had. So right there, he stopped my black belt project. He says, you already met your, but my point is, even in healthcare to this day, when you look at things, you really got to make sure that what people are telling you and everything, that you do the data. The data is gospel.
You said a key word, Six Sigma is a myth buster. I've been in so many places where they've held a belief for 20 or 30 years, but the problem's still happening. And then you start using the data, and the data tells you it's something completely different. And then when you improve that process, that input, all of a sudden the problem goes away. I can tell you a quick story. I worked with a company that makes rims, wheels out of aluminum. And for years, they believed that the problem in their process was coming from where they casted a wheel. But that was a couple of steps up. And we went in and we started taking data and we looked at things like the SIPOC, right? And the SIPOC, to me, kind of tells us what's happening upstream in things that are being fed to the process.
Yeah.
And I said, is there any data that you have on your forge? And they said, well, I don't know. We've got PLCs that measure it. So I looked at the capability of the forge. Nobody ever measured that ever in the whole life of this company. And found that there were these huge swings in the forged material. And we found out that there one of their team of employees were putting ingots on a forklift and then speeding up to the forge and then stopping and letting the ingots go off. So if you put ice in boiling water, what's going to happen to the water? The temperature is going to drop significantly. So we found that that was really the problem. And then through the use of regression, we
Oh,
started
yeah.
to understand what was the thermal loss that was happening between the forge and the different casting pots. And we came up with a mathematical model that told you exactly how long you had based on the heat in your forge to get to one of these casting pots. And this is using regression and DOE,
Oh, yeah.
but it's a 30-year problem that they all of a sudden focusing on something else and using data and stats. I'd like to hear a little bit more about how stats kind of works in a hospital environment. I know that when you're looking at time, like you probably change over your ORs constantly, right? So if you're looking at the changeover time between ORs, and that time should be pretty consistent, and then you run a control chart and you see that, man, it's all over the place.
Yeah.
Then
Well,
that
that's a good point. I mean, so all our leaders at the hospital are some type of black belt, and then the key leaders are just off the chart, lean Six Sigma type persons. Well, when they go around, they go around to all these management, and they all have KPI boards. Just the questions they ask is all data driven. You know what I mean?
awesome.
It it kind of injects the people that are actually responsible for their operations to do it. The other big strong part for any kind of data is infection control. I just am involved with surgical services, but you walk through that hospital and they have analysts all over the place analyzing data using data tools.
Wow.
So it's embedded everywhere in healthcare, I'm sure. Well, you look at the back of a medicine bottle, right? They all that is based on samples and all that kind of stuff. So
That's amazing. You get back to something called it's Gemba management. You have analysts, you have probably CNOs, you have different leaders in the hospital that walk around to each of the individual places and look at their lean boards, and maybe it's a LCD screen or something to make sure that they're managing things at the processes and not from an ivory tower or in
yeah.
some boardroom.
I got to tell you, my whole career, once any of the plant managers or whatever got subjected to breakthroughs, that drove their Gimbas. Let's go see. I'm thinking back. I know right now at the hospital, I work with a guy. The first thing out of his mouth is, if there's any kind of problem, let's go see. It does help. You get more support, and everybody sees the problem the same way when you get these executives going to the workplace and actually see what's going on. But that is the best part of what I'm doing now as helping the senior staff is they take down any barrier or constraint.
I think it's part of an infrastructure. So if you're going to have continuous improvement in a company, what I see is people come to us wanting to be a green belt or a black belt. They're just trying to get a credential, and you get these leaders that send these people to our class to learn to be a green belt and then come back and their job is to save the world. And I tell them in the class, that say, you have been set up for failure. You're
Oh
not
yeah,
going to go back and change the world, because you're going to go back and you're going to have leaders that have no clue about Lean and Six Sigma. They have no clue about how to pick projects. And so they're going to give you a project like move this from here to there, or justify this improvement, or help me build this new facility. None of those are process problems. Those are just things that they want you to do.
yeah. Let me tell another thing that I learned is in manufacturing, design engineers and nurses. So here's the correlation between them two. A design engineer, his whole DNA is to make something non-standard, special, custom type thing and have an urgent, and their drive and urgency is one thing. Nurses, they don't have the time. Six Sigma, to get to the root of a problem takes time, and they don't want to hear that you have to go test something or do something. And so they're more reactive. Like I said, they remind me so much of a design engineer. They come up with a thing they think is going to solve the problem on the fly by that part of their brain, and then just go do it. And what happens is, if you don't take the slow approach and only change one thing at a time, you just keep running around trying to find the problem, a shotgun approach. So let's say, and I'm making this up, let's say the infection rate went up and now they're running the data and they think they found out it's 4 or 6 when they do ortho cases. So instead of going and trying to look at breaking down all the elements and doing basically a failure mode analysis and prioritizing it with the team of experts, they just go get everything that they send EVS and the nurses and they scramble and they did something to affect it. So they're very happy about it. But then it comes right back. You know what I mean? So they didn't walk through the whole Six Sigma process.
Right. It's a Band-Aid effect, right? I love nurses. My mom was in healthcare as well, but I've seen it. And they have to be that way to
Yeah, they have
survive.
to. Patients first.
But if I constantly do that and I don't improve, it's chaos. And so they're used to that Band-Aid effect. They're used to putting a Band-Aid on a wound, or I call it being a firefighter. So I run into a fire, I douse the fire, then I run into another fire and douse that. But the previous fires, it's smoldering and then it pops up again.
You know, you find you almost have to at times do both. You have to just do whatever you can to make sure that you're comfortable, that things are stable, and then you got to somehow take the time to follow up and try to break it down and see
Right. Yes.
what effect has what.
So my book is the infrastructure. So if you don't have an infrastructure for continuous improvement in your hospital, if you don't have KPIs, key performance indicators, if you don't have targets, then you're just going to constantly be reacting to problems. You probably have 20% of your problems that cause you 80% of your pain, but if you're just reacting to every problem,
Yeah.
so you put things in place, or this companies put things in place like gamma management, making sure that we have data analysts that analyze the data so that we can react in the short term, in the long term, understand what caused that and get rid of it, thereby making things better and better and better.
In healthcare, in the last probably 15 years, they're big on huddles now. You know, at first it was a safety thing, but now I see, especially at the hospital, they have a safety huddle every morning, and that has a big impact because it sets the priority on what they should be working on, and it alerts everybody. So that's a big one in healthcare these days. In manufacturing, it took a while before some of the senior people would actually come, but you could see the impact because it shows, all the employees, it opened their eyes that, that they were there and listening to what they were saying. So that's a big culture thing too.
Again, getting management to go down on the floor. So when you have that division between leadership and what happens on the floor, I saw it so much. The leaders, they stayed up in the ivory tower, and then they sent their minions down to tell the people on the floor what to do. And the people on the floor, they're the ones making the product. And it was such a division that, and companies that exist like that don't exist long.
You asked me offline what was some of the biggest struggles. I have to tell you, I worked at K&L Microwave, went to Wire Mold in Philly, and they were walking me around, and I said, "What's that area over there?" He said, "Oh, that used to be all the managers' offices." I said, "They're not here no more?" He said, "Oh, no, they're here. They're out. We moved them out on the floor." So I went back to K&L Microwave, and there was a brave man running K&L Microwave back then named David Howitt, and he allowed me to present him a layout of closing down all the managers' offices and putting them out on the production floor. And so we
Excellent.
had cells of the quality, materials management, the operation management, and quality control. They all sat next to each other. So they rebelled on me. They hated me, and they said, we have to have this big meeting. So 2 months after these cubicles are built, I go in and see Dave before the meeting. He says, don't worry about it. And so he went around the table, said, what is the problem? He said, I can't get nothing done. And they said, why? And they said, well, these people keep having problems. And then he went around the whole table and said, well, QC, what's with you? Well, they're bringing all these bad parts. And he says, that's exactly what I want them to do. It kind of was eye-opening to me. Those barriers that would turn into emails or all this other stuff were gone. They were accessible out on the floor. And now they're complaining because the direct employees were not allowing them to do their work. That,
Wow. Wow.
yeah, that
That's
was a big one.
amazing. They built a culture that you broke down. That's amazing.
They're still working. I see people all the time, and they're still laid out in that format. The cells for the. but that was a big one.
Experienced something similar that you've got design engineering that's in most production facilities, and they're usually separated from everybody else. So you've got management, you've got engineering, R&D, HR, stuff like that, and then you've got the people on the floor. And the people on the floor are experiencing the design falls of design engineering, but you have to walk half a mile to get to them, and nobody's going to do that. We did the same thing by moving design engineering into the process, into the places that they were designing for without walls. They were out in small desks because they had to see what they were doing. And so all of a sudden their process design just skyrocketed.
Now in healthcare, they're growing so fast, at least in our network or whatever, they grow so fast that they can't put things by design where they really need to be.
Sure,
You know what I mean?
sure.
So you want to go talk to the educator. You say, where is she? Third floor. And it's not their fault. It dwarfed and it grew into this big enterprise, and they just have to put people where they kind of have them. But slowly but surely, they do. We have planners and people on site that actually have some experience with flow and things like that. So it does change. Or any new place now, like these new surgery centers are going to be small ones are going to get their own sterile processing instead of having them come to the main campus. So things like that they do for efficiency. They're moving to that way. And manufacturing, the manager's door had a glass window so you could see if they were on the phone or they're doing things. In healthcare, they're solid. No matter where I go, there's solid doors.
So the constraints are kind of built in.
Yeah.
But that's probably because that building's been there for a long time,
Oh, yeah,
and
when you
as
do
it
the value stream
expanded,
map,
so you start looking at things like a spaghetti map, and you see a huge amount of movement.
when we put the people in the cells, the good side of it was they could overhear if quality was on, like the design engineer and the manufacturer engineer were sitting near each other, and somebody would come in with a quality, you'd literally see them spin in their chair saying, "What?" You know what I mean? So it was through osmosis. They were getting all this
Right.
team
Yeah.
building through osmosis. So yeah,
All
it was
the
pretty
all
neat.
the information was right there. That's amazing. Yeah.
If you Google, you'll see on one of my articles the visual factory. I was a big person of that, the visual factory, and I put monitors out in the mill so people could see what's going on. We had quick response teams. The biggest thing you can do is make it visual, and that's part of 5S. The biggest thing I learned with 5S, because I had a lot of 5S's that failed, was they
Yes,
have to be self-sustaining.
that's
And so
right.
I said to my general manager, "What the hell you mean self-sustaining?" He says, "When you leave, when I walk up to that area, I should know what it should look like." So he made me do border address labels. And so he would walk around, and if he saw things out of place, you knew in a second. And so that's how it was self-sustaining. In central processing, as soon as you walk in, there's an and-on light, and so that's part of the visual, and a nuisance alarm. So if when these carts that they put the instrument sets in come down to an area to be cleaned, and the carts have to go through a different workflow through this big square box that cleans it and disinfects it. Well, that's a constraint. If you don't constantly take them out, it gets backed up and decontaminated to the point they have no space. So we have a light that blinks and then an alarm. So it forces people to go pull it out of there. When you walk into the central processing, we're also responsible for pumps and things throughout the hospital. You would see on a wall where the pumps are. The pumps, to replenish it, we can have two pumps, but if we go to three, where there's three pumps missing, we're gonna have to call and go get one. So behind the third pump, there's a picture of a hand that says "Go get." So it's a very visual sign that when somebody hands out that pump, the feeding pump, they know they got to go find it before they run out of completely out, and then they're not going to have it when things. So throughout the whole department are all visual. We do also 1 point lessons. So you have your standard work, but if an event happens that you have to take immediate action, we have a Word document called a 1 point lesson that we show them what the problem was and what we did to fix it. And that's posted right on the doors so people can see that everybody signs off on it. And then it goes on the door. So when they're going in and out of the door to go to lunch or leaving, they have these things right in their face that are 1 point lessons for the day or the week or whatever. And then they get rolled into our standard work.
Let me ask you a question. What was your most unexpected obstacle you encountered during a Lean Six Sigma project?
Two things really. One is when you're with a team, they want to always problem solve with the expensive items. They don't want to do the little tiny improvements. They want to come with a new computer system, and then they kind of equate that to the management not supporting them. All the times I get involved in these things, I got to be very careful and just say, listen, before we even start, this is not about multi-million dollar solutions. We need to brainstorm to get solutions that are practical. That's the frustrating thing with me is people just jumping ahead. And then the other one is, I was going to say the other part of that is when I get assigned a project, you probably feel this too. When you walk in to a project, they pick a target area, they have a breakthrough, or they want to pick a target area for improvement. And I walk in, I do an assessment of attitude and behavior. And I equate it to a little boat. If I don't have enough rowers and enough people cheering at 68 years old, I go back and say, well, I'm not doing it.
Right. That's awesome.
You
Wow.
gotta have there's gotta be a little spunk and passion involved in there. So those two things are probably the toughest things.
That's all the time we have for this episode. I want to extend a huge thank you to our guest, Eddie Conklin, for sharing his incredible insights on how Lean and Six Sigma are not just manufacturing buzzwords, but essential tools for creating a more efficient and effective healthcare system. His stories about applying these principles to everything from surgical room turnover to managing inventory truly highlight the power of a data-driven approach. Thank you for tuning in to this episode of the WTF podcast, From Factory Floor to Operating Room. If you enjoyed this conversation, please subscribe to our YouTube channel. It's a completely free way to support what we do. Make sure you're following the podcast on both Spotify and Apple so you get every new episode instantly. And of course, we would love for you to leave us a 5-star review. Join us next time as we continue to explore the world of operational excellence.